Hello everyone, my name is Pedro Canning. Today we're going to be talking about engineering ethics. So to start off the presentation, I'm going to give a short story about the Challenger shuttle. Back in 1968, NASA had a shuttle program and they were set to launch their Challenger shuttle and the morning of January 28th. When the clock hit T-0 for the launch, the engines ignited and black smoke started billowing out of the sides of the two complementary rockets for the shuttle. The rocket still proceeded to go upwards, and after 73 seconds, the rocket catastrophically exploded, killing all 7 people on board. It's known as one of the saddest days in aerospace history, and immediately after, NASA decided to launch an investigation to see what exactly happened. Even though internally they knew it was the O-rings that were holding together the two sections of the complementary rockets together. So to first understand why this design was chosen, we're going to look into the company that made it. So Thiokol is a company out in Utah that was contracted by NASA to make to manufacture the two SRBs, or the solid rocket boosters. These are 2 small rockets that you see on the side. They were made in Utah in certain sections. So parts of the rockets were welded and parts of them were assembled in Florida. And where there were joints that were being assembled in Florida, they needed O-rings to seal to make sure combustion wouldn't get out. They chose this design because shipping a whole rocket from from Utah to Florida was very dangerous to have all the solid rocket fuel in one spot. So this design was going to work well, but the temperatures in Florida for the date of the launch were well into freezing temperatures. They were set to be in the 20s and 30s, in that range. And the engineers over at Thiokol recognized this and decided that there was probably going to be a problem, and so they brought it up with NASA. So in the days leading up, after NASA had heard about their concerns, NASA scheduled a teleconference, and in the teleconference, they would discuss the probability of failure. So before this meeting was happening, Thiokol hosted a small meeting of their own, and they decided that it probably would not be safe to launch. But in the first teleconference, they did not voice their concerns very well. Luckily, there were bad connection issues, so there was a second conference, and in between the first and second conference, Thiokol went out and they gathered all their information, sent it off to all the right people for the teleconference. In the second teleconference, they voiced their concerns more thoroughly. They were met with opposing views from NASA engineers, and in the end, their vote didn't count, and the managers at Thiokol instead voted to say that they were ready for a launch. So we're going to see how this relates to the NSPE Code of Ethics. This is the National Society of Professional Engineers, and they have 6 what they call fundamental canons. These are going to be the main portions of their code, and if you follow this code, if you don't follow this code, it's you're not going to be prosecuted by the NSPE, but you are liable to have your professional engineering license taken away from you and even prosecuted for public endangerment. So all these codes are just mainly in place to make sure that your engineering decisions are for the good of the community. So your decisions should keep the safety of the public paramount. You should not work in fields that you don't have experience with. Give your professional opinion on those fields. You're supposed to be a good worker, things of this nature that help you to be a professional engineer and uphold the integrity and the honor of being an engineer. So when we look at what exactly happened in this case, we're going to look at NASA and their engineers. NASA was very reluctant to cancel this launch. So you can say that, or many people speculate that NASA was so reluctant to cancel because if they kept getting postponed and postponed and postponed again, that what would happen is they would lose funding from Congress. So some people speculate that the reason that NASA was so happy to launch was that they had conflicting issues, or sorry, that they're trying to protect the company instead of the well-being of the people in the shuttle. The similar could be said about the managers from Thiokol. Some people speculated that they made that decision to protect their contract with NASA, and the managers voted to launch. Some people also say that the managers weren't in the right position to be voting on that. The managers were engineers, but they didn't have experience in rocket O-rings. Finally, we look at the actual engineers from Thiokol, and in my opinion, they had the best, most sound ethical thinking out of the groups. They did make a mistake when designing, that they didn't have O-rings that can hold up to the environment, but they recognized the problem and they voiced their concerns. So this really shows the importance of engineering ethics, that it's not just the engineers that have to follow it, but everyone surrounding the industry